Hello once again, guys. I welcome you back to my YouTube channel. So if you haven't subscribed, make sure you do subscribe. So today I want to do with power machines and 5, which is chapter 9 and chapter 10. And chapter 9 is steam condensers, and chapter 10 is condensing of water required. Remember, we have different instruments that we can use to condense steam, or we have different type of steam condensers that you must know. So firstly, you must know the purpose of a steam condenser. They're saying the function of a steam condenser on a steam plant is to receive the exhaustion steam from the engine or the turbine and condense the steam, and to deliver the condense to the fab pump. So you must firstly know the function of the steam condensers, and also the different type of condensers. I'm just going to mention the few that I have. The type of condensers: we have the surface condenser, we also have the evaporative condenser, the jet condenser. Okay, so those are the different type of condensers that you must know, and you must also know how to define what you call the bottom law. All right, okay. So basically on your chapter 9, they're talking about different type of condensers that you have, and then we go to chapter 10, which is they call it the condensing water required. All right, okay. So the first thing that you must know on the condensing of the heat is that whenever there is a loss of a heat, there is also a gain on the other side. That's why I write here the heat loss of a steam is equal to the heat gain of water. So whenever the steam is losing the heat, you must also know that the water is also gaining. So that's why they came up with this equation, whereby this is the heat of a steam. The formula to calculate the heat of a steam is going to be HF plus X, which is the dryness fraction, plus X plus HFG, okay, minus HC. And then also the heat of a water is going to be the mass of the mass of a water multiplied by the CHC of a water, which is sometimes to be given, sometimes it won't be given. If it is not given, you take it as 4,187. This is T2 minus T1, which is the final temperature minus the initial temperature. And then you also have the formula to calculate the total pressure. So you have two formulas to calculate your total pressure. The first one, if you want to calculate the total pressure, it's going to be the pressure of the pressure of a steam, which is PPS, and you also have the pressure of the air. So you can also get your pressure of the steam on the steam table. Remember on my previous videos that I was doing, you can also get your pressure of the steam on the steam table using the temperature. And then you can also, so the pressure of the air can also be given, or you can also calculate it. And you also have another formula to calculate the total pressure, which is going to be the barometer minus the vacuum, or close the bracket, multiplied by 0,133. So these two formulas, they will help you to calculate your total pressure. So it will depend if you are given the barometer and the vacuum, or if you are given the pressure of the steam and also the pressure of the air. And remember, I also said on the enthalpies, your HF, you are going to get it at the given pressure on the steam table, same as the HFG, you are going to get it at the given pressure on the steam table. And then your HC is the same as as HF. So don't confuse, when you go to the steam table, you can't find HC. So your HC is the same as as HF. You're going to get it at the given temperature. You are going to get your HC at the given fab water temperature. So sometimes they won't specify like this is the fab water temperature. You're going to choose, you'll be given the initial and the final one. So you're going to get your HC at the final temperature. So basically, this is the formulas that you must use. So we are going to do an example of this with my students, and then you are going to understand more about this. So basically, this is the formulas that you must know when it comes to chapter 9 and also chapter 10.